gotta spend a little more on them.
Or get this, the 65K variety, the really bright ones. Yeah, I've noticed some of the new cars now, they've got LEDs on them and they're obnoxious. They're obnoxious.
They have gone crazy with LEDs on cars.
Yeah, if you don't have LEDs in your car, that's near and out. Yeah.
So I want to be obnoxious. I don't want to hit me in the ass.
Well, yeah. Well, you're doing a pretty good job there, right? See if this is. Uber has been texting me. That's a text from Uber.
Oh, your car's here.
And you reply to them, and they say they don't respond. They don't answer it. It's a broadcast only. So I've gone to the FTC today to see if they can do something about it. They have a method to do that. It's probably like the National Do Not Call list. It's a national do nothing list. They do nothing except, I think when you get on the list, you get more calls. It's the only thing they do. Oh, yeah. Renaissance Energy called me again about the third time. I said, put me on your do not call list again and turn them into the national do not call list. So we've been around tinkering with robots for a couple of years. Ray, one of our sometimes members, shows up. He has a laser cutting business, and he cut. See if I have it anymore. He cut a robot for us, and we put it together as a standard for the club. It's that guy right there. Ray cut all that and did a great job and assembled it. Actually, he bundled it and made a package for us. And it's just a two-wheeler with a tail dragger. It's a tail dragger. It has a ball on the end that it rolls on. So that's was our first club project. And then Leroy does a lot of projects. We got various people contribute. And a lot of people are interested in stuff like that. That's cute.
What's on the back? Is that how it changes direction?
It's just a caster, just stabilizing.
It's a follower. It's a tail dragger. It's like the tail of a plane. The way he drives it is this wheel goes faster or that wheel goes faster.
They change speed.
Yeah, controls the speed of each of the wheels.
Mm.
And if the left one's going faster, then it's turning right. And if the right one's going faster, it's turning left. You control the speed. You got an encoder on these? Sometimes they have encoders.
It doesn't need it.
Okay.
It's actually using one of your tricks.
Oh.
It works pretty good.
So can it make tight turns or not really?
Yeah.
They could probably turn a circle. Just turn on the axis. Should be able to.
Are we ready to do something with it?
Sounds like it. It's in the time. It's time to. Are you ready?
I'm sort of ready.
So I'll put battery pack in the title. So I need that fixed up next week.
What we need to do though is have it calibrate to the room, and so it doesn't get a whole bunch of heat signature sitting around it. So I'm going to do something over here first. And I don't know how many, if you can see it or not. There's a couple of LEDs up here that'll turn green. when it gets the background sensor temperature worked out. And then the green LED tells me it's ready, the other one. You see how
Frank.
sensitive it actually is? I just moved it a little bit.
Oh, okay, it sensed your hand.
It senses everything.
It's looking for heat though, isn't it?
Yeah, these temperature sensors are really, really sensitive. Like, to the extreme.
So it's a heat seeker. Can find my hand.
Is it going away from heat or towards heat?
It's going towards heat. So,
I don't think so. I think it's mad.
It's going towards you.
well, that's because I'm
He's
heat.
a bigger radiator than his hand.
That's
Oh, okay, it's kind of following the right side.
Yeah, well, that's because the one wheel doesn't want to spin right.
Yeah, it keeps going around until it sees you and then it just wants to come back. Hello. Oh, there we go. New target.
Well, then
Does it?
Oh, and it gets too close, it stops.
It gets too close, it stops.
That's cool.
So,
Or hot, as the case may be.
let's move the camera over here. Let's see if we can. That should do it. This one wheel doesn't want to spin all the time.
Is it turned in?
Yeah,
Let's see.
it's a cheap kit.
No, that's our standard reading. Just can't guarantee that they'll all be good.
Oh, we see you.
yeah.
Hello.
Move it a little further over here. Yep, there we go. Oh,
It turns toward the bigger heat signature. You
yeah.
got the hand,
Your
it's
hand,
small, and then you got the big radiator.
Yeah.
and it's gonna go
Whatever,
toward the big radiator.
whatever.
Yeah, you just kind of have to do this really.
That one wheel's not spinning. You can hear it.
Oh, okay. Yeah, you got to start it.
Yeah.
What I do, I try to kick it up and then back down.
Well, I did, but I think it's the battery.
Oh. Wants a drink of coffee? I don't know.
That one wheel's not spinning again.
Oh, okay. Yeah, you're gonna have to put the encoders on there, bud.
Well, I'm going
You can
to take
see,
it.
you can see kinda.
I'm going to take it apart.
Maybe get far enough away.
It's never. I'm going to use these sensors for something else, I think. You can see it moving straight, more or less.
Right.
But it's doing one of your tricks. It's
It's reading,
yeah, it's snaking.
which is what the line tracers do, but you just can't see it.
Because it does it so fast.
Yeah.
What do you mean?
It worked real good for my pepper spray.
Line follower.
Once the
Line
dog
follow
gets real
through
close to it, it would automatically spray them when they get
And
near.
there's like a sensor
After heat
that
signature.
looks at the line and it'll just follow the line. But it really just goes back and forth.
It would do it to anything.
Why?
Yeah,
That
wow,
seems
It's
to be
not
less efficient than just having both the wheels.
It's not
go that way.
discriminating.
No, it's for
So
guys.
if you got
One
your-
reason for the line tracers is
Yeah.
if I want something to go from here to
Then we would
there,
need Wi-Fi. or
and I don't
some
want
kind of
to be
something
real
like
complicated
disarm
about it. Just have
Couldn't
it follow
move
a
it
line.
towards-
Simple.
I just put a piece of black tape down on a white background and then follow the tape.
Mm.
Has some photo sensors on the bottom. LED replacement for fluorescent.
Does this work?
I haven't tried it yet. I just got it in the mail today. It's 6500K, which means it's very bright.
Yeah.
Should be very bright. So I'm gonna try those out on the utility room.
Yeah, I replaced almost all of my fluorescents, the regular bulbs with LEDs.
Oh,
They're
okay.
a lot cheaper now.
Yeah, well, they're getting cheaper.
They're a lot cheaper than they used to be.
Yeah, that's true.
$5 a piece.
$5 piece?
Yeah.
Where'd you get them?
Costco.
What?
Costco.
Costco? Oh, okay.
Were you
That
gonna
one
turn
is
that
a-
on and have it like
I mean, this
go to
is,
the light? Is that what we were
Yeah,
doing?
that's what we should do.
Come to the light.
That would confuse it. The light would be everywhere.
But that's your light follower.
Yeah.
The very first one.
Oh, okay.
That's what I got. Where I just said, do this, do that. Turn the motor on, turn the motor off.
Oh, okay.
And you saw it when it actually senses heat. The LED changed from green to red, which showed which LED or which
directions.
sensor actually triggered. The right sensor actually works the left motor, and the left sensor works the right motor.
So how often will it switch?
It's real fast.
Can we put it on the ground and have it follow someone around? Or not do that?
It probably won't work real well on this carpet.
Yeah.
It's not quite right now, but you can see the concept. But
It's not right because it's not doing this one. It's this motor.
it's wheel. Yeah.
It's either the motor or it needs a couple more batteries in it.
What I did, some of my code is I kept both motors on. Both motors were on all the time. I had a minimum and a maximum. And both motors were on, except when it wasn't on, it was at a lower speed. And both speeds were high enough that it would come on. Both, yeah, you had to adjust the numbers high enough where they had both run. That's
I
the
think
problem.
this motor's bad. That's what I think. I
Well,
don't.
you can adjust left and right in there. You should be able to adjust left and right, and just adjust left up.
It's already at
Max.
It's as fast as it's
Oh,
going to
okay.
go.
So it's probably the motor.
It's probably the motor. I think this
It should be.
either that or it just doesn't like running on 4 batteries.
Oh, okay.
4 batteries.
Not enough?
Not enough.
Oh, okay.
Yeah.
They're what are they? They're 6
1.5
volt.
volt.
They're 6 volt.
Yeah, that'd be 6
They're
volt.
6
code.
volt motors, and I'm running it on like 4 volts.
Oh, okay. So then all bets are off.
Yeah. So that's why I ramped it up. I mean, it's going as fast
Oh,
as
that's right. You got to run the
possibly
motors on it. Yeah, they're 6 volt motors. Okay. I got it in the notes now.
They're
Save
6
it.
volt motors that can run it at 9 volt. But these are I2C devices, and obviously they have the same I2C address. So that's what the multiplexers do. And you got one multiplexer for SCO and one multiplexer for SDA. And I'm just switching them back and forth real fast. I've only created one instance of the thermal sensor.
You're adding complexity.
How am I adding
So you-
complexity?
Okay, you have a SCA, you have the 2 signals, and usually you only want to do that with one device, and you're switching back and forth.
He's saving the last one from each one. He's switching back and forth and saving one value for this one value for that one, just going back and
And then
forth.
what do you do with the value?
He controls the
It's
wheels.
used to figure out if it sees heat or not. So
Okay, so you tell
these-
one wheel and then the other wheel whether you see.
Right,
Why
So-
can't you have a channel for each,
because these are on the same, they're on the same address.
okay.
And you can't put 2 of the same address on the I2C bus. And there's no way to change the address. So I could have stuck a second processor in here, or I could have done a multiplexing.
Okay, I understand.
Second processor would have really complicated things. Multiplexing just switches stuff.
You have to admit that's a little twisted, but okay.
Why do they have to be on the same address?
Well, what's twisted is I only have 2 sensors. I'm using like 8 lines to control 2 sensors when it really only needs to be 2 lines. The sensors I2C devices come factory preset with a certain
Address.
address to them. Some of the devices, you can change that, so you could use more than one device on the same bus. These,
Those are matched.
yeah, you pretty much,
Fixed address. So we've got
whatever
two
it
devices
is.
with the same address.
I've got one I2C bus on the Nano. So multiplexing it seemed like the best option to go. It just seems weird because, I mean, the multiplexer is capable of doing 16 different devices. I'm only doing 2, so it seems weird that I'm using so many lines to do 2 devices.
And it seems weird to us, and we're with him every week. Okay, so yeah, it's a
It
little
seems weird to me too, because I mean, I'm
when
taking,
Leroy says it's weird, then it's weird.
I'm taking something that's running off like 8 lines down to something that could possibly run
So
off
what
2
are
lines.
you turning power to each one of the multiplexers back and forth? Or
No.
enabling them?
No, remember when we did binary? This is just binary. There's 16 numbers.
I know what a multiplexer is, yeah.
So it just switches highs and lows on the input side of the multiplexer. And then there's a signal line. So the signal line goes to either STC or SCA. Here.
So you got to be turning the multiplexers on and off. Are you turning the multiplexers on or
At
off?
some rate, what's the rate?
Well,
Oh,
as fast as
But
it
you're
could get
you're
through the
connected to
loop.
both of them. Oh, okay, you got one connected to one connected to the other. Okay. So you
If
just
the loop is too fast, it seems like you get into oscillations with the way the thing moves.
you just look at it like it's live numbers. All you got to do.
Yeah.
Well, he's getting 2 numbers, and they're both live, kind of. Okay, so both multiplexers are on all the time, and he's just operating this multiplexer. He reads that one, and he reads this one, back and forth. And the output is 16 bits, and he's looking at the bits. It's easy enough.
So that's all you're doing with these multiplexers. So this is hooked up to, I don't know, pin 12, pin 11, pin 10, pin 9. I know that's not right. So you just switch bits on. I'm only using 2 of the output lines. So I'm really only switching 1 bit.
So you're using the output line for the clock. Is that what you're using to switch the clock?
No.
The output? Okay, you got a multiplexer.
Yeah.
Show me how your multiplexer is connected to the sensor. Just draw this is easy. This is not hard.
This is where it's connected to the sensor.
That is a bit matrix. I'm talking about wiring. Here's your multiplexer, boing, 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 boing. And you got a sensor here, and it's connected to what?
Gems, yeah.
Okay, this is what? C0. And this is an output or an input?
Yes.
Both. Oh, it's I2C. Okay, so you got a common.
No.
You got.
No.
Okay, you gotta have 2 wires. Sorry.
Yeah, there's 2 multiplexers.
Oh, both of them have to have 2 wires. You're talking about a ground.
No. So this is connected here, and this one's connected here. This is the SCA.
Okay.
This is the SDL. Or, yeah, whatever. You've got pin 12, pin 11, pin 10, pin 9 on the Nano. These pins switch the outputs.
That's the big one.
Okay, so your
It's actually quite spectacular.
So this guy, this is talking, thinks it's talking to I2C.
It's actually impressive.
What does it think it's talking to? This output, it's multiplexing. Okay, so this guy, you're multiplexing these points via I2C, and these show up in the table somewhere.
No.
Listen to me. I mean, this is easy. You got a multiplexer out here. What multiplexers do is they bring information out. Okay, they're bringing information out, but it's I2C information. So you're bringing an input in. SCL is a clock. Okay, it's coming out of the multiplexer? No? Okay. What's connected to this wire?
SCL.
That's what I said. Okay, SCL is, you got a sensor up here.
Uh-huh.
And you're connected to the sensor to the multiplexer.
Uh-huh.
Okay. And the other wire, and that's SCL. The other wire is, what's the other one? SCL and
SDA.
SDA?
Yeah.
Okay, it's going to be connected to the other wire.
Not on one multiplexer, no.
Not on one multiplexer. SDA is connected to more than one multiplexer.
No,
SCA.
no.
Going down the
There's
rabbit
two
hole.
multiplexers.
Okay, I'm just connecting one right now.
Then you're only connecting one line.
Okay, so the SCL goes to one, the clock, this one goes to one multiplexer. Where does the clock go? Are your clocks together?
Clock goes to here.
So the clock goes to here. This is SCL. This is SCL. This is SCL. Okay, SCL is this going to, so this is, both SCLs are going to one multiplexer? Okay, so that's the clock. So you're clocking off the same multiplexer all the time. Okay, and then the inputs, you're taking one input to one and one input to the other. Is that true? You got clock and you got data.
Mm-hmm.
So you're taking data
You
to
got
one and data to the other.
Data goes on to one.
Data goes on to one. Okay. The data for this one goes on to the same one.
Input
Oh, okay.
going to two motors. And you only have one address.
So the clock is,
So he's explaining
okay, so you're running both the clocks
how
off of
this
this
works.
and both the data's off of that. Okay. And you're toggling back and forth over here.
And this is how you toggle.
Okay.
You switch. That's how you toggle.
So
So
the
if you
outputs,
had 3 sensors hooked up, you would
He's trying to
toggle.
control the movement.
That would be 0. E9 would be 0. P10 would become a 1. And then it would toggle C3 here on both of these.
So this is the clock.
No,
This is what?
it's the toggle
What are you talking about?
toggle multiplexer.
So what toggles the multiplex?
Binary.
You're shoving this number in, and then this number in, and then this number in, and then this number in into the multiplexer value. Is that what you're doing?
Side going out to sensors. There's C1, there's C2, C3, 4, 5, 6, 7, 9, 0. This is the switching side. This is the SIG, which is the signal which goes to any pin. This is where the input. So what happens you have these connected to various pins. I'm just gonna say, make some pins up for now. This signal line would be connected to SDA, for instance. It could be connected to anything. It could be connected to an analog value. When you say 0, 0, 0, 0, here, all lows on these 4 pins, all it's doing is going ching and making a line like that. So when you make 12 of 1, it switches it like that. So it just connects this signal line to whatever's connected out here.
So you're pushing, okay, that is telling you what value to push out to the multiplexer. What set of values you want to push out to the multiplexer.
This here is just telling you which sensor you want to read. It could be all up to 16. I've only wrote 10, but it could be up to 16.
Which sensor you want to read. And now the sensor is a discrete input.
If you had,
But the sensor is, in this case, is a binary output of the sensor.
Basically, you're using like a 74138 multiplex
I don't
data
know.
selector.
I don't think that's what that one is, but yes,
Okay,
I don't know what that one is.
it's the 7400 series logic chip,
What
and
noise?
you don't necessarily need to use. It's high speed. There are some that are analog based. They're just data
That's,
selector, and there's some that are discrete based, so they have to be TTL level.
this one will read the analog.
Okay, so that one probably was like described as being like video data selector, or
No.
could be video. Well,
It could be anything.
yeah.
Okay,
Because
So
it's capable of doing an analog.
So it's an analog version of a 74138. That's cool.
the output of the photo sensor is a binary output, right? It's sending out data. Is that correct?
Okay,
It's sending out a value,
okay.
and that output is connected to an analog input.
Yeah,
Okay.
if you want to.
And both of them are connected to the same analog input? Is that true?
Well, I've got 2 of these. So one of them.
And that's why I said, are both of them connected to an analog input? Yeah, that's a yes or no?
Yes.
Okay. Is it the same analog input?
No.
Okay, so they both have an analog input, okay. And you're sending out an address to these guys to say, read that. Okay, so you're just switching which analog input you use back and forth. Okay,
Except that it's not analog, it's I2C.
it could be, okay, it could be discrete input or it's some sort of input.
It could be anything. I could hook LEDs up to it and just tell it to switch LEDs on and off. I don't know why I would want to do that, but I could.
Okay. So this is your controller. You're saying that's a signal to the multiplexer.
If we had 16 of those heat sensors, which we could do, this is how you would switch it on and off. All 16 of them. You just change the inputs here.
So what's changing the address, the input? You
I-
have 0001.
Oh, you need to make sure it's a latching. You need to make sure your chip is latching, and it has an enable on it. If you're going to be
there's an enable, yes.
no, but it also has it has to have a latching.
Okay.
That way, when you set the data onto pin 0 and then you enable it and the latch, then you change your data address to like pin 2, the data that you set on pin 1 stays there and it doesn't just disappear.
Okay. Then these do not, they don't latch.
Okay.
It-
I ran into that. I did this like 17 years ago.
These particular ones don't latch. These are just,
Okay.
they're just stupid. They just switch. I didn't put the enable and all that. It's, the enable's just basically tied to ground anyway.
Okay.
So you're defining which address that these are being, which address range. You should probably take it in groups of 4 or whatever.
I was thinking with the
By
latch.
doing this, you can say, take the first set of 4 and move it over. No?
No, 000 connects those 2 pins together. Internally, inside of that mux. That's all it's doing. So whatever's sitting right here on 0 is also sitting right here,
So that's an output, you're telling me.
or an input.
It's a bidirectional
That's one
multiplexer,
bit at a time. Is that what you're
demultiplexer
trying to
with
tell me?
latch.
It's one bit at a time, multiplexing?
No, seriously, it's a 74HC4351.
We're just trying to get the concept down.
Yeah.
It's a 49, 23,
What's that?
66, who cares? We're trying to get the basic concept.
Oh, no, right here. That-
Please, you just didn't know the
These are
numbers.
pins on.
It's, but,
This is the
I mean, it's just a bidirectional.
Okay. Also,
channel
those, the
latch.
nano pins are connected directly to that.
nano.
Okay.
This is the sensor side.
Okay, when you select 0000, it takes a block, or it takes, what is this, CO?
That's how they're numbered on the thing.
What is it? It's a discrete input? It's analog input, just tell me what it is.
It's input or an output.
A discrete input or output, okay.
Say discreet, he'll be okay.
And it takes this and put it, okay, so this is, where is that sig going to?
In my case, it's going to SDA, SCL.
Okay, so you're just using that as an output, multiplexing that output there. Okay, and you got other stuff going on. And this SCA is also down here?
No.
No?
That's the addressing.
That's your addressing scheme, okay. When you're addressing them, you're saying, when you use address 000, what's it telling you? Only one?
Only one.
You're only using one output at a time?
Because only one of the wheels can go at a time.
It's only,
No, both the
it
wheels
can
can
only
go
read
together.
one
Wait,
sensor
both
at
the
a
wheels can go
time.
at the same time?
It's reading one sensor at a time. Okay, but it's
You're just
also,
shifting through them.
okay. Okay, and this signal is an address or information. No, you're taking that and putting it into the analog input
What
or
do you mean by
to the
shifting
input
through
of
them?
the nano.
Okay.
Okay, so this is.
Have you ever
another
done
input.
a 7-segment display?
Yes.
Okay, so it has like the top piece of the 8, the bottom piece of the 8. So yeah, the whole 7-segment display is based on persistence of vision. Okay, all the letters aren't on at one time. It just blinks this section,
Okay,
that
I give
section,
up.
and the next section, and it does it so quickly, going through all these segments that your eyes can't tell the difference. If you were to photograph it, you would see these pieces turning on and off. It's kind of cool.
Okay, what else you want to do, Leroy?
I don't know.
There's not enough
You don't know?
logical
That's it?
output pins to drive all the little segments.
You done?
So
You
you
done?
scroll through an addressing system to turn on this piece of the display, that piece of the display. And those are some really cheap old multimeters that used to do that.
Frank?
This is kind of the idea.
Help?
So if it's doing that, only one wheel's actually
It's
going.
happening
there.
so quickly.
I don't
Sending
really know how
data
else-
back and forth.
how else-
Oh, I'm not gonna understand it here. I'll
All
have
you
to
do is
dig
say,
into it and see.
you know,
I just don't understand.
this
And it's just a difference
grab
in the way my
information.
mind
Yes,
works,
grab
as you guys may
information.
admit.
Addressing each one of the sensors. If
No,
you
no,
have
let's,
maybe if you
let's,
look-
we beat it
if
up
you want
enough.
to
You know, we
use
tried.
The
Hey,
address
I'm not gonna catch it this time. That's not uncommon with me.
Use it in the reverse
It
direction,
physically, it
so you
looks
can set-
very much like I drew.
That's with
sort
the
of.
So it's
demultiplexer.
being set only one at a time.
Yeah,
Then once it's set.
it's being
This
addressed,
is multiple.
addressed one at a
So
time.
this is physically
So
what
he
something
can
like
address
Ray is talking about.
number one, and it can come
Yeah,
to you.
it's probably the same
Yeah, that's
multiplex
number
that Ray's talking about.
Okay, well, he
I
goes,
don't remember what model number it is.
Okay, so what's the relationship between?
so it's his choice whether or not that 10 gets to be input or
There's
output.
no
but it's addressed.
relationship between the
So once he
multiplexers
sets
and the
up
wheels.
like address
The
3,
relationship is
which
between the
would be like,
multiplexers and the sensors.
Okay.
0011,
You got a sensor, and
pin 3 will
multiplexer
be
is gonna let you,
selected,
um,
and he can
scan
either
each
read
sensor.
So
sensor information from it,
C0
Or you
on
can
both,
turn on
on both
information.
multiplexers,
and
C0
then
is
he can go
connected
number
to,
7 if he wants to.
I don't know which one it is, say it's connected to the
That
right
number
one.
7, it doesn't have to be
So when
Sensor
it's
or
0000,
he can actually use that as
it's
an
reading the right
I2C
sensor.
Okay.
channel for the moment.
When it's
So just because it's only selected for
0001,
code doesn't mean that
it's reading
it's set
off
or
of
forgotten.
C1,
Okay,
and it's
It's
reading the
there.
left sensor.
got it. And what do you do with that?
He just
Feed
data-
it into the
Data
nano.
multiplexing.
Well, there's a little bit of math done inside the
Okay, so
nano.
you read in that, nano, you do some math, and then you,
Then these, whatever these values are, relate to what the wheels do.
Leroy's pretty smart, he's just not that great at
it's
explaining.
more than just see. I understand what you're doing.
Okay. Frank got it. Well, there's hope.
Now, he's still got some stuff in there that we can't see, because he's got an algorithm.
There's a little bit of math. You want to see the math?
No.
Okay,
No. Okay.
If the multiplexers confused you, the math isn't that bad, really.
Yeah.
I'm cheating, actually.
Well, I never.
We kind of expected that.
Well, I ended up, instead, I wanted it to actually be based on the temperature, but I ended up turning the temperature sensors into simple switches. So they do actually sense the temperature, but instead of trying to compare the ambient temperature to a new temperature, I just said ambient temperature is going to be equal to 100. The new temperature will be equal to either 0 or 100. And then you do some subtracting on the motor side, and if 100 minus 100 is 0, the motors don't move, and if it's 100 minus 0, then the motors move. So it just turned it into a switch.
It's a very ugly
Yes,
contrast threshold, yeah.
yes, it is.
Yeah. Okay.
But
Maybe you can get
but
that.
these sensors were so freaking sensitive when I was playing with them. They were just sensing everything, and I could not get it to weed out. So that was the way I got it to just lock onto
Okay,
certain things.
You're on the way to a patent.
I doubt it.
Are the sensors analog or?
Uh,
Because the
What-
temperature sensor should be analog, but he's saying that he's not really using it like that.
Okay, I was gonna say, you know, depending on how they're feeding information back to you, you can, you know, use capacitors to smooth it out, or
you don't have access to them. It's all done internally on the.
You're getting a
on the
number out of
ITC.
ITC.
Oh,
You're getting a
okay.
number from
There's
ITC,
a,
right?
there's a little microcontroller inside of them. You just don't have access to mess with all that stuff.
It's giving you a data each
So I
scan.
cheated.
so the ITC is just giving you flaky information, you think?
No, these things are really, really, really accurate. If I could load other code up, you could see, even in the same room, when they're pointed in different directions, just slightly, they will tell you different numbers.
There are other capacitance that maybe people don't think about. Have you considered possibly putting a metal clip onto the temperature sensor? That way,
It's
Maybe
an
I'm not looking
infrared,
at-
it's an
it's infrared.
infrared
My bad.
sensor. Yeah. He's just getting a digital value. And it's like a value going into a register.
But
And it's
I'm taking the temperature and turning it into a digital value is basically what I'm
Well,
doing.
if you're talking to an I2C doesn't do analog. It presents you a number every time, a number.
Yeah, well, you could.
And he has no adjustment to the sensor.
We might be able to just like track the last 10 values that
Yeah,
and
you could do the averaging.
But it's actually how I started it, was with averaging, and it still kind of got a little flaky. And when it first starts, when I first started up, it does some averaging.
Yes.
Sport room, cool.
Yeah, we got to change the name on that, don't I?
Yeah.
But which conference room is it? Okay. Hello,
robotic board.
new member?
You could see in the original code where I actually wanted it to actually compare temperatures, and it was way too sensitive for
It's
that.
probably looking at a very tight area, which you could see how that would confuse it. Yeah.
Yeah, I'm pretty sure that these were used for like the in your ear for the temperature thing for kids.
It'd be interesting to see if you could point it at a heat source and see it vary just a little bit, move it slightly, and see
It
how
does.
sensitive it is. Is it wacky sensitive?
It's wacky.
And
sensitive.
pinpoint, okay, pinpoint
I
accuracy.
took a lighter and I went,
Oh, yeah.
and it just lit up like that for a second, moved it away, right back to being cold. They are extremely accurate, and when you go out with the float, if you read out with the float, they're ... 0, whatever.
Oh, okay.
I mean,
Is it possible to use a lens?
maybe. I'm not going to mess with that though.
Yeah, it'd be interesting to see how sensitive it is. It may be it probably is very distance sensitive.
Arabian.
How much you pay for these sensors?
I got them for nothing.
Nothing.
No expense was spared.
No
that's what-
expense was spared. People at IC Station sent them to me. They're about $8 sensors.
Wow.
So, yeah, they're not horrible. And for how sensitive they are, they're well worth $8.
Can you send me something on the information about them? Be cool to look at.
He has a link in the meeting notice.
Sorry, I just got off of
You
an
don't read the
airplane.
meeting
I
notice?
just got off of an airplane.
We went through this last week. Who was it last week?
So I didn't get that, but
He's always getting on me for not reading stuff. So it's my turn. I get to beat on somebody else for a change.
So, unless you guys want to see the code, that's pretty much what I've got. Do you want to see it work now?
Yeah.
Because I know some
I do.
people walked in here after the fact. Hopefully I can get it to not see all these people. Oh, red lights, that means it sensed temperature from something. TV maybe. Maybe.
If you turn it away, how long does it take it to reset from reading temperature?
It's still pulled up red. There's a lot of heat right now. Okay, if you went green, where are we going? Where are you going?
I think it may be distance sensitive. Yeah. There we go.
wow, that's awesome. So it has like a,
It has a distance monitor too, so if it gets too close, it should stop.
This won't go. Oh, stop.
You're probably on an angle with the distance sensor.
I think it's seeing too much heat right now from everything.
It's seeing both of your hands, it looks like.
I see my arm.
Steer it over there. See if it sees that. Hello.
Could be the air, man.
Who's hotter?
It could be. That's one wheel. That's one wheel. Yeah, we need to get a better battery pack for that thing. That's one of our issues. Yeah.
That's cool though.
Got a warranty on those wheels. That's a battery.
It's the battery.
Yeah, those are 6-volt wheels is what he's saying. And we're trying to run them on 4. We're being overly optimistic.
What kind of chassis frame is that?
It's just a cheap one.
$2.98.
Right?
Just had to jab you a little bit.
I know. I'm using yours for something else. Actually, you
Come ahead and
missed
get
it.
another one.
I actually used the quad rover, and you missed it.
Sorry. Been running my butt off with
All right, so it's more or less working, but there's a lot of heat in here right now, and it doesn't really know where to go. That's the other problem that I found with this is there's no real way to tell what it actually sees. It just kind of sees something. It's hot. I'm going to go that way. We were playing with it. Hattie walked past me, and it saw her and took off following her, and I'm like, what the heck? Come on, robot. You're supposed to be following me.
Okay, good. That was good.
Unless people want to see the code, I did. The code's on GitHub, on my GitHub.
Is it on C? What is it built on?
Arduino, yeah.
Did you put it on the meetup, like a link
Yeah.
to it?
It's not on the meetup.
Not on the
I'll
meetup.
show you.
It's on the.
When we've got new guys here, there's a meeting announcement up there. When you join, I put you on the mailing list, and we'll send you this weekly announcement. It's very similar to meetup. And I got to not follow that. Up here, you got the meeting, and that's a link to the meeting announcement page, this page. It's up to the minute, whatever the latest thing that I or Leroy typed in. And the meeting, so that's the link to the web page. If you want to see what we're thinking about for next week, you can go look at that. It may or may not be accurate depending on how busy we've been. Here's a link to the meeting videos. This club's meeting is being videoed. We try to put them up there, keep them up there for people who have no life, like Ray, for example. When he's in Albuquerque or parts unknown.
Cool.
Orlando.
Orlando, okay.
What were you doing in Orlando?
I just dropped off 2 laser machines for Universal Studios. Spent a couple days down there at the
I'll swap you seats.
prop shop.
You're all right. No. You're
A
all
couple of weeks ago, we saw Vincente with his $3 camera. Was that last week?
right. That was last week.
That notes for that are in there, and also there's Leroy's work area. There's the announcement for this week. I go through and cut these out and paste them into an email and send them. I clean them up, so you don't see everybody's stuff, just whoever's active this week. There's Jeremy, security probably. That's our guest. The Video Rover project link. That's what Ray made us a kit. The Video Rover, what we call this guy here.
There's like 6 rovers now. 3 more on the way.
He printed these and put together a kit and offered them to the club members. It's pretty nice. It's a tail dragger. Let's see. Also links to the members' projects. If you get active and you want to do demonstrations or you want to share something, if you want to share something, I'll give you a page. It's on. It's basically on Google. The Google. What do you call it? It's on Google. It's a shared folder, basically.
Drive.
Yeah, Google Drive.
Yeah, that one.
Cloud, what I was trying to say.
Google something.
So you can see Leroy has a bunch of stuff up there. Frank, Art, Vincente is a later contributor. So we have stuff up there. And if you have projects you want to do, which we encourage, well, at the end of the meeting, we'll be looking for if you want to do a project or give a presentation. Jeremy gives presentations regularly here about security.
Don't you owe us one, Jerry?
What?
Remember last time you were here, you were talking about a presentation on.
Nah, we try not to push anybody, and
I've been busy, so.
we don't try not to criticize. This is a freedom from fear. We try to do freedom from fear. So when you come up here and you
No
feel
bullying.
free, no bullying, just have fun. And so you'll get this meeting announcement, and then you can go look at the live meeting announcement if you feel motivated. Or you can not read it like some people do, and then, but basically you'll get the topic. People will see the mail and say, oh, well, there's a meeting, that's right, and here's a topic. And then we move that up to Meetup also. So what's your name?
Cool. Well, my name is Cameron.
What's your interest, Cameron?
Well, I saw his automation, and then I saw you guys were doing like Arduino, and I was like, sounds fun. Like, I've not done any of that actually. Like, I typically like code websites and like Python and like, C++. So
Python, C++, any of that makes you happy, Frank?
yeah,
He's with the real people.
I have not been able to.
Yeah, so,
yeah. But well, lately it's a lot of like, unfortunately, like PHP and stuff. So.
you don't like PHP?
I call it like cowboy coding.
Yeah.
Where you're just like, right.
Well, that's the way it goes these days. It's cowboy code everywhere.
Yeah. But that's what I do. So I work for supposed to have a coworker come with me, but work for Snow Commerce. So like we do like e-commerce platforms.
And PHP.
Mostly.
You guys using a framework of some kind?
We use Magento.
Yeah, well, that's why you don't like PHP.
Yeah. But it's not bad.
Okay. Well, you got some good resources to find kits like Ray has. Are you offering your kits yet, Ray?
I got about 30 of them, 40, 60 of them, something like that in the shop right now.
Okay.
They're all the black styrene,
I've already seen it.
Oh, okay.
all those are
Good luck.
they're sitting in the boxes ready to go.
We hang around them
Just
enough, we
pass it
know
along.
that means they're unbreakable.
Yeah,
Oh, yeah?
they're-
Okay.
That's cool.
What are they exactly?
Unbreakable.
They're unbreakable.
Just be careful, the breadboard
We need to get a
didn't
link.
come, it didn't attach.
This is tall droid.
Yeah,
It's pretty cool.
You want to put them on the screen, Ray? You got a,
I don't have a Chromecast. This is an iPhone. I don't know how to do that. Maybe I could, but I don't know how to do it.
you'll probably get Chromecast for an
I-
iPhone.
I think you can cast,
This is one of the smallest ones that I
You
have.
should be able
So do they come with like an Arduino and all the accessories, or what are they?
It has a ultrasonic distance sensor, a servo. This one is the compact rover, and it has a Uno on it. The antenna mast there is for either Bluetooth or you can put a Wi-Fi on it,
or a compass.
or a compass. Yeah. And the reason that we started putting an antenna mast on there is to put the compass as far from the motors as possible. But then it just became a joke to have everything with everything that gets an antenna mast.
You didn't really see that.
This is the final design of the video rover.
So my question to you is
Here you've
about
got
this, like what are these? Is that the distance sensor?
ultrasonic distance
Distance
servos,
sensor?
an
These are
LCD
the
in the back,
Ah, okay.
antenna mast with Bluetooth, Wi-Fi.
These two red
stuff,
boards
whatever.
are the multiplexer,
Um,
and that's
Arduino Mega.
microcontroller.
I have no idea.
Uh,
And your name, sir?
I know that's
That was the thing I was
Don?
trying to
Okay.
explain.
Okay, let's,
That was your last one.
Two wheels.
Oh, okay.
You
I
can
meant
either
how do you
pre-program or you can connect to your phone.
connect to your
And
Well, it could be Bluetooth or Wi-Fi. And I'm currently in the process of writing Arduino code and iOS code to control them from the phones.
Oh, cool. An app.
What's that, an app?
Yeah.
Yeah.
Okay.
It would be neat to control them from the web with PHP.
He's trying to give you something to get in.
Yeah. There's some frameworks called like Cordova. There's some other ones like Xamarin and stuff. And what they do is you program a web app, and then it will generate both an Android and an iOS app. So you don't have to natively do both of them.
That's cool.
Yeah,
You might
that
wanna
was
look
simple
into
apps and
that.
such. Although you will still, I'm pretty sure you still need you need a Mac to compile for iOS still. Don't
Yeah.
you?
Well, I mean, if he's doing iOS development, then he's already got one.
Yeah.
Yeah.
And then you'd have to natively do the Android one too.
Yeah. So I was doing the Android development, and I was using my older laptop. It's not old, but it has an AMD A8 processor, and you can't do virtualization of an Android on screen
Oh man.
with an
Don't-
AMD. So I had to buy a new laptop.
Can you not do Android development on an OSS?
You can, yeah. It's just that, like, if you want to do
I wanted a new laptop.
The
so I went and
virtual-
bought a new laptop.
like the emulator is not the fastest thing ever.
Yeah.
Not most of
It's
it.
not great even on Android Studio. You end up using a real device.
Yeah.
Yeah, I carry around with those too.
There are ways you can accelerate the emulator depending on what sort of hardware you have, and that can get it to somewhere where it's actually okay to use, but it's a little bit tricky and requires some setup.
So I bought a laptop with the Intel i7.
Shows up here.
But the most expensive laptop you
I could
could.
find, yeah. It's nice.
Does the emulator move faster? You tried on i7?
I've been so freaking busy. I am lucky to
It
get
should be a lot
Android
better.
Studio
Dude,
installed.
if it's an Intel, I know there are alternative builds of the emulator you can try as well if you need to.
He was saying something about the Quad Rover. It's just a 4-wheel. And I'm working on a 6-wheel. So, and it looks more like
It's like a really long, skinny thing.
no, it looks it's
All that
like
automation stuff.
big, but it looks. What's the advantage of having 6 wheels instead of 4?
the back 2 wheels are set, and the 2 front
Oh,
wheels
the Nano
they
is
cantilever back and
basically
forth,
a small one.
and it just allows them to
Nano.
be able to go
that's
on
the
a
control.
non-flat surface.
This
It
this
looks
little guy right
a bit
here,
like a
the
Martian.
microcontroller.
But why would you use like
It-
Nano or Uno?
Those things have 6 wheels.
Well,
They need to flip
All
over.
6 wheels are driven.
Depends on the
It's that little yellow
Actually, there's a couple more.
gearbox at the bottom of
Believe it or not.
the wheel arm.
Choice of microcontroller is either based on the project that you want to do or size restrictions or your own personal
Or what you've got laying around.
preference.
Yeah, sure. Or whatever you got laying around.
Or whatever you got laying around. In this particular case, I felt I was limited on space, so I went with something a little smaller. I could have just as easily used a Mega, but a Mega would have been way overkill. for this.
Cool. But I like your versions of Overkill. Good.
Well, the 2 Mux boards on there are way overkill for this thing.
Well, I think what you're doing is not necessarily going for overkill. It's going to say, hey, I could use 15 sensors. I could use 32 sensors. And this is
How to
the
do
starting
it.
structure of DD at them to do it.
Basically, I have 2 sensors that are on this, that have the same address. How do I use them on the same bus? That's how to do it.
And there must be sensors that you can change the address, right?
if I had two sensors, I could change the address.
Do they exist? I mean,
Yeah.
Let's say you bought a
They're more than $8.
$15 sensor
Oh, for this particular sensor,
for that type of sensor.
I think you can, but I haven't seen them yet. So the data sheet says something about being able to change the bus or change the address, but it doesn't appear to work. So
A challenge is something on your sensors. Use the sensors without the multiplexers and see if the load on the sensors is causing the flaky data. See if the lack of consistent load. You know what I mean? Because if you're addressing them and that chatter might be causing your data to flicker.
Okay, I see what you're saying, and I wish I could load other code on here because you'd see that it's not.
Okay.
They're very, very, very consistent about what they're reading.
Okay. If you feel good, that's fine.
When they're pointed at something, and we're doing actual temperature readings, they're extremely consistent. They might jump just a hair here and there, but they're extremely stable.
Could it be messed up because the signature of all of the people in this room is just varied? It's just all over the place, and you can't predict what's going to be at any one spot.
That is one of the things that I was afraid was going to happen, because how much do we all?
98-degree radius interacting.
Yeah, there's 900 degrees in here right now or something.
Seems to be.
But
What are we cooking?
But that's why I was trying to point it away from the heat, so it could try to get a different ambient background temperature.
Jim, I missed your LED
So
thing. What do you got going on there?
I bought some, they're replacing the fluorescent tubes with LEDs now. I finally broke down and bought some. I'm paying $10 a piece, and he's buying them for $5. Where is it?
He's getting them at Costco.
Costco, man.
Okay.
wow.
I bought
How much are these?
270 of them for about $11 each. There is we actually bought a couple different ones and stripped them apart. There is definitely a quality difference.
Oh, okay.
There's the biggest, easiest thing to see in the quality difference is in the little power supply board. There's a little power supply board in them.
Mm-hmm.
Is this double-ended or single-ended?
There's metal tips on both ends. I don't know.
Okay. Stay away from the single-ended because they'll arc and spark later. Because if somebody installs them into a non-converted chopper ballast. So this one can use a ballast or not.
Yeah, I believe so.
Is it compatible to like 90 volts all the way up to 270, or is it just the low volt?
I don't know. I'm buying for 120. So these are 6500K, 6500 Kelvin.
Blue.
Huh?
Very blue.
I haven't. That one's just came in. I hadn't got it in. But very bright is
Somebody's making a
going
lot
in
of
the
noise.
utility range. So I'm looking bright is okay.
Wow.
So you think of the blue light?
That is painful.
Yeah,
We'll plug it in.
it's ready. I mean,
You give yourselves migraines?
No, if I'm walking in a noisy environment, it's very distinguishable. There's no doubt about it. It's my phone.
I guess so.
And if I'm in an airport or wherever.
That's a 20-watt version there.
All mine are 18s.
Okay.
They are, neutral and hot on the other end. They can be driven 90 up to 270 volts. And I picked the 4500 temperature range because when you're in a room like this with all the different colors, we want to be able to see warmer stuff, not the blue.
Okay.
Me and John, a friend of mine, actually drove over to Indianapolis where they were selling these in the warehouse, and we put a fixture full of 3,000, a fixture full of 4, and a fixture full of 6, and 5 or 6. And you could see the colors as you could walk by the lighting, just to see how, what my clothing looked like. And what we came to was that in an area where you've got colors like would be in a retail store or an art studio, you definitely don't want to be at the higher number color range. The 4,000 really looked best. So,
Okay.
Why don't you want to be at the higher end of the range?
it looks blue. Everything looks blue, and
Colors wash out, I guess.
it's really harsh on you.
I feel blue.
Yeah.
And these are going in the laundry room, so. What you show?
That is my new speech synthesizer and voice recognition.
Okay. Speech synthesizer.
You have,
Is this Darth Vader or?
you haven't tried it out yet.
Yes, I've tried it out.
So now the hero, we can just say, turn right, turn left.
It's,
And it's going to synthesize back to you. Bite me, bite me.
it's, $89 for that.
Wow.
Yeah.
I got it on sale for Black Friday for
Well.
$69.
Oh, Leroy bucks.
Next week I want to put it on probably one of the bitty bots.
Cool.
So now how many phrases?
It's independent, does not need training, does not, it's run Linux. It's a low Linux computer that sits on top of the Arduino. And it works mostly. I gave it a couple of phrases and it reacted to them oddly, but you've got to apparently do a lot of logic inside of your sketch to weed out some of the bad phrases. But it works mostly.
And you don't have to
You
train.
came back.
I came back. You do not have to train it.
Oh. All right. We have another? Yes.
I saw it in your email.
So why would you need a hardware device for that? Couldn't you just have some software on a computer with a mic? Like,
Okay.
I mean, like,
That is a computer with a mic.
why do you need a
It's a lot of
special
software.
one? Can't you just
Well,
attach a mic to any
For the
device?
Arduino?
the
Arduino doesn't have
Arduino's not capable of doing good speech recognition. I mean, it's only an 8-bit device to start with. But if you could conceivably connect it to a computer and have your computer do the recognition and tell the Arduino what to do. But what if you want to do a robot or something that you want to carry around with you?
So
Now you're
so it's powerful enough to do that. All right, that makes sense.
This thing has, this is SD card slot.
Yeah. The SD card slot contains the voices apparently, so don't mess with it.
Can you change it or is this fixed?
It's from what you can, but it's pretty much set. From what I've read, you really got to know what you're doing in order to
Compile a voice.
change the voices and whatever.
So that won't be till the week after next.
Yeah, something like that. But if you wanted to do something mobile, away from unwired, you need something like that. Raspberry Pi, the new Raspberry Pis are probably more than capable of doing it. But
Even then, you're taking up a lot of your processing time.
right,
To do a voice or to wait for a voice or
and it
to synthesize when your main processor could be doing something else.
right.
And Leroy's case with the Hero robot, he had several processors doing different tasks that he was delegating to from another processor.
From another processor. I had a master processor and 6 sub-processors all doing something.
Lots of synchronization.
Lots of trial and error.
There's Leroy's Hero Jr. from Star Wars Day.
Drinking Pepsi.
How many processors did you end up with in that?
There were seven total, and that doesn't count the MP3 player. So if you count the MP3 player, there were 8.
Cool. So what vintage was that? 80s?
What does it do?
Right now, it sits in pieces because I took it all back apart. But we used it for Star Wars Day, and it was a little demo. I had a lightsaber attached to it, and
It
It's saying-
backwards and talk and sing and.
Dance a
danced
little bit.
around. It was kind of meant for little kids. Really enjoyed it.
Oh, I loved it.
That's why.
Yeah, it was good.
Little kids really enjoyed it.
Yeah, exactly. I think you nailed this.
That was one of those projects where I thought about sticking a Raspberry Pi in it at one time. Actually, I was going to stick a Beagle Bone in it at one time and went with Arduinos.
What's the advantage of the Beagle Bone? Is it just more powerful?
Not more powerful.
How does it compare to a Raspberry Pi?
It's got a lot more-
Powerful than that too.
It's got a lot more I/O on it too.
A Beagle Bone is very similar to a Raspberry Pi, but it has a lot more I/O.
A lot of I/O.
And the amount of memory, the base build on it, the frequency, the processor speed.
I had the Beagle Bone. Right now, I like the Pi better than the Beagle Bone because of standard kind of Linux kind of stuff.
Which
It's
distro are
easy
you
to
running?
install things.
Which distribution are you running?
What's the newest one? 3. And
Python
I use the standard,
or
the distribution that came with it.
Raspbian?
Raspbian, yeah.
Right now, I think I emailed you and Jim, but
Yeah.
MCM has the older model Pi, the B model, as a kit for $19. You get a case, you get a nice big thick book, which is very out of date now. Power supply and an 8 gig SD card for $19.
That's good. It's a good
So
deal.
it's a
I
pretty good
haven't had
deal.
a chance to take advantage of it yet, but
Um,
just because maybe wanted to.
When I was up there yesterday and got mine, he said they were getting very, very close to selling those out. Apparently, they found them in the warehouse up there, so they were ready to make them go away. And they hit the right price, $60 down to $20. It's good for me. Not that I need another Raspberry Pi.
You never know.
Well, the book's good as long as you're not stuck on the. You know,
The
2-point
new
kernel.
stuff, yeah.
Yeah, you can go 3-point kernel, you're fine.
Yeah.
So what does this do right now?
This is a temperature sensor. It's basically it moves towards the heat.
Oh.
So we could try it again one more time if you'd like to.
Yeah, sure.
Sorry.
It doesn't sound right though if we say, see how hot she is. That just doesn't sound nice, so.
We're going to probably have to look out your message.
You gotta get sued over that now.
The other thing is, with the better lights, it has, basically half of it is aluminum extruded bars that dissipates the heat that's
I
on
think
the
it's still
LEDs.
solid.
And the lens that's over that is actually, it pushes the LED.
I don't know where it's going.
Somebody catch him?
It's performing better.
Yeah, a lot.
I was stopping.
We
It's
must,
gonna stop.
Okay, you can see the lights changing.
yeah, we must have cooled down enough.
Yeah.
Or something?
It likes the laptop.
Oh, it went right
Yeah,
to your-
that's-
It does like the back of the laptop.
Yep, that's very warm.
Somehow it's working better.
So it should stop.
Yeah.
less heat. I moved back away from it when I tried to get it to calibrate
okay.
that time.
It's got two sensors down lower.
Yeah, the sensors are lower, they're not.
The one wheel's
Oh,
not
the wheel's
spinning.
stuck.
Oh, yeah, it is.
You broke it.
There you go.
Your coffee.
Is this your phone?
Yeah, your coffee might have been.
Yeah, it can't control the wheel. The voltage is too low.
I'm sorry.
Is this
Coming to you.
something
What's up,
do
what's up,
for
what's
fun, or like, is it
It's much.
Yeah, but we should just
That's a
turn
lot of
around.
fun.
That doesn't really-
How much still left?
Yeah. You broke it. Now you gotta fix it.
It's coming after you. Don't let it bite you.
Very nice.
So,
Cool,
yeah,
though.
when it actually calibrates to the background temperature more correctly, it works a whole lot better. So I think that first time it saw way too much heat because both LEDs were red, whatever.
All right.
But that's the basics of it.
Well, it sounds like you need some elves in your factory, Ray, to crank out a bunch of bitty bots and get them on Amazon.
Now, what I need is somebody to make some assembly instructions. And once the assembly instructions are ready to go, then I'll turn my website on for sales. Then I might need a dozen or so elves.
What's his name? Brian assembly instructions?
Yeah, that wasn't the ideal manual for someone who just pick it up and look at it and let's go. You remember the Heathkit days, right? Heathkit made